All right, today we're going to pull back the curtain on something that's, well, kind of running our world: algorithms. These are the invisible, step-by-step instructions that are secretly powering pretty much everything, from your Google searches to your social media feed.
I mean, have you ever stopped to wonder, how does your phone know what you want to see next? You open up YouTube or TikTok and boom, it just serves up the perfect video. It feels like magic, right? Well, spoiler alert, it's not. It's actually a set of instructions, a kind of recipe, designed specifically to figure you out. And you know, that magic feeling is exactly what Francesca Rosella is talking about here. She's the co-founder of a really cool wearable tech company called Cute Circuit. And for her, algorithms aren't just some dry, boring science thing. Nope, they're tools for creativity. I mean, her company uses them to make clothes that literally light up when it gets dark. It's just a simple set of steps, but for the person wearing it, it absolutely feels like magic.
Okay, so what is an algorithm really? At its absolute core, it's just this: a sequence of logical, step-by-step instructions to get something done. That's it. It's basically the rule book that a computer follows to solve a problem. And probably the easiest way to wrap your head around this is to think of it like a recipe. Seriously. If you're going to bake a cake, you follow specific steps, right? You've got your ingredients, you've got the method, and you get a cake at the end. An algorithm? It's pretty much just a recipe for a computer. Let's take this smoothie recipe, for example. This breaks down the three key parts of pretty much any algorithm. First, you have your input. That's your stuff, right? The fruit, the yogurt, the ice. Then comes the process. These are the instructions. Blend for 30 seconds. And finally, you get the output, a yummy smoothie. Input, process, output. Remember that, because every single algorithm, no matter how crazy complex it is, follows this basic model. Okay, so we've got a handle on what an algorithm is. Now let's dive into where you can actually find these recipes out in the wild. And trust me, they're everywhere. And a lot of the time, we don't even notice them. I mean, they are absolutely everywhere. Think about it. Google's famous PageRank algorithm? That's what decides the order of your search results. The weather forecast? Yep, that's run by complex algorithms. And that list of recommended videos on YouTube? As one Google engineer put it, that's a super powerful recommendation algorithm at work. It's the same thing with Shopify suggesting products you might like, or TikTok building that For You page that knows you, maybe a little too well. But it's not just where they're used that's mind-blowing, it's the incredible scale. Jackson Gabbard, who was an engineer at Facebook, puts this number out there: 1.2 billion. That's how many users they had to serve. Just let that sink in for a second. And as he points out, when you're operating at that kind of scale, your algorithms have to be insanely efficient. They have to be fast, and they have to use as few resources as possible. Think back to our smoothie recipe. A recipe that takes an hour to make one smoothie is fine for you at home, but it is completely useless if you need to make a billion smoothies a minute. That's why efficiency is it's absolutely crucial. All right, so we've seen the big picture. Now let's zoom way in. We're going to get our hands dirty and walk through a really simple algorithm, step by step, just to see how it actually thinks.
So we're going to use a classic sorting algorithm called bubble sort. It's a really straightforward way to take a totally jumbled list of numbers, like this one right here, and get it into the right order. The mission is simple: turn this mess into a nice, neat 1, 2, 3, 4, 5. Okay, so here's how it works. In its first pass, the algorithm just looks at the first two numbers, 3 and 2. It asks a simple question: is 3 bigger than 2? Yep. So it swaps them. Now our list is 2, 3, 4, 1, 5. Easy, right? Then it just scoots over to the next pair, 3 and 4. Is 3 bigger? Nope. So it does nothing. It just keeps doing this all the way down the line. It gets to 4 and 1, swaps them, and by the end of the pass, you can see the biggest numbers are starting to bubble over to the right side. But as you can see, the list still isn't sorted. So what does the algorithm do? It just starts over from the beginning. It does a second pass, which gets us a little closer to the goal. Then it does a third pass, and now we're getting somewhere. With each pass, it just systematically gets things a little more organized. And there you have it. The algorithm will do one last check, see that no more swaps are needed, and then it stops. We have a perfectly sorted list. Now, look, bubble sort is great for showing how this works because it's simple. But for a billion items, oh my gosh, it would be painfully slow. And that's why real-world systems use much more complex, much more efficient algorithms. It's all about picking the right recipe for the job.
So before a programmer actually sits down to write code in a language like Python, they plan it out. They use something called pseudocode. And as developer Ivo Janch explains, it's basically just plain English that describes the steps. In fact, when I just said, compare two numbers and if the first is bigger, swap them, guess what? That was pseudocode. It's like a blueprint that lets them figure out the logic first without getting bogged down by all the picky syntax rules of a real programming language.
So we've seen how powerful and efficient these things can be. But what happens when the recipe is wrong? What happens when these super fast, massive scale algorithms have a bug? Well, the consequences can be, let's just say they range from kind of weird to totally catastrophic. Let's start on the kind of weird end of the spectrum. For a little while back in 2011, this was the price of a single book on Amazon. A book about flies. So what on earth happened? Well, two different sellers had pricing algorithms that were programmed to outbid each other. They got stuck in a crazy feedback loop, and the price just shot up into the millions. A tiny algorithmic error with a truly bizarre result. But yeah, the stakes can get much, much higher. In 2022, a huge outage at Rogers, a major telecom company in Canada, took down everything. We're talking internet, payment systems, even 911 emergency services, all gone for hours. And the cause? A flawed update to the networked algorithms, which set off a disastrous chain reaction that basically crippled a huge chunk of the country. So how in the world do engineers stop this kind of thing from happening? Well, the short answer is they plan for failure. They use clever strategies like canary releases. Yep, just like the old canary in a coal mine. They'll roll out a new change to just a tiny group of people first, say 1%. If anything goes wrong for that small group, they can immediately hit a rollback button and undo the change before it breaks everything for everyone else. Building reliable systems isn't an accident. It's something you have to design from the ground up. Okay, so we've covered what algorithms are, how they work, and even how they can go spectacularly wrong. Which really brings us to the big so what question. Why does any of this actually matter to you? Well, because understanding the recipe behind the magic is it's a superpower these days. Whether you actually want to build these things as a software engineer, or maybe you use them in marketing to shape culture, knowing how they work is critical. It empowers you to ask better questions about the tools you use every single day. And honestly, it just makes you a smarter, more informed citizen in a world that is completely run by these invisible instructions. So I'm going to leave you with a little challenge. The next time you're scrolling your feed or you get a recommendation on Netflix or you type something into Google, just pause for a second. Ask yourself, what's happening behind the screen here? What are the steps? What's the recipe? Because the cool thing is, now you actually have the tools to start figuring out the answer.